I'm going to go ahead and run this, and we get down and we stop at our familiar location, and I'm going to look at that address. I'm going to say, please give me the address where we're going to assign it. We step over that line, and we see the 255. There it is, just like what we wanted. But now we can see a little bit more. When we step into foo, right, here I go, I'm going to set this foo variable to equal to 200. And so now what should be happening if this stack thing that I said is true that I just told you about, right? I should be able to find where it's going to stick that value, and it should be close by because all we did was kind of grow a little bit there. So let's see if we can find it. I don't know if it'll actually save it for us. Let's see here. That is foo variable. It is at 790. So where is 790? 790 would be right there. So there it is, right? You can actually see it right there. And our previous value that we were looking at before, the test pointer value, was 87F, which is right down here, right? And it's at 0 because we wrapped it. So there is the value that we had written to in this function. That was where it was on the stack. And then here is the next location on the stack. Now you may notice that there is full banana cake stuff happening here. Like, where did all this other stuff happen? Why did it put them so far apart if this stack is just growing? And the answer to that is actually because there's all kinds of shenanigans that actually go on with the stack in debug mode, which is what we're compiling in here, where you can, basically the compiler has settings which put stuff in there that try to help you from making a mistake. It'll basically put in stack frame checking and padding regions and all these other things to try and help you from errors where you might be writing if you're actually doing some of this pointer manipulation that I was doing. So a bunch of this stuff we don't need to worry about now, but basically what's happening is when it pushes the stack, even though it really only needed to go a little bit to store this one simple integer, which is only 32 bits or whatever, we only need to store that one thing. The reason that